This video is on Unit 1, Chapter 1, Lesson number 6 on inequalities. Just as a reminder, an inequality means that it's not equal to. It might be greater or less. That involves your greater than or less than. And I have included something right here. You may want to jot that down just as a reminder of which one's which. In your notes, graphing inequalities, there are two bullets here. It says use a closed dot when you're graphing greater than or equal to or less than or equal to symbols. You're going to use an open dot for greater than or less than. Notice that the difference there is one has a line underneath the symbol versus no line. If there's a line underneath, it's closed. If there's no line, it's open. Interval notation is a shorthand way to write a solution to an inequality. In interval notation, it's a way to write the solution to an inequality using infinity symbols, parentheses, and brackets. Parentheses indicate not included or open. Brackets are going to be used to indicate included or closed. I would also like to include here or say that parentheses are also going to be used for positive and negative infinity because we cannot include infinity as a point. It's not an end point. Okay, so let's look at example 1 and 2. The directions here tell us to graph each inequality and write the solution in interval notation. Number 1 says x is greater than or equal to 8. So I'm going to, on my number line, I'm just going to put some numbers on here. And at 8, because it says x is greater than or equal to, it's going to be a closed dot. And what you're shading is any number that's going to make that true. So any number that's greater than 8 is going to be to the right of 8. Now, for interval notation, again, we're looking at the two endpoints. And we always go left to right, just like we read and do math. We do all of that left to right. So how far left is everything shaded? That's an 8. How far right is everything shaded? It goes all the way to positive infinity. Now for your ends of your interval notation, again, parentheses are going to indicate not included or open or an infinity. So I'm going to put a parentheses around that infinity symbol. Brackets indicate included or closed. At 8 is a closed circle, so we're going to put a bracket around the 8. So again, interval notation is just a shorthand way of representing what you have graphed for an inequality. Number 2 says a is less than negative 1. So again, I'm going to stick some numbers on here. And then at negative 1, there is no line underneath that inequality symbol. So at negative 1 is going to be an open circle. Less, I'm going to shade anything that's less than that, and anything less is going to go left. So we're going to shade left. For my interval going from left to right, left is negative infinity, to right is a negative 1. Negative 1 is an open circle, so that's going to be a parentheses, and infinity is always a parentheses. So again, interval notation is just letting us know that everything is shaded from negative infinity to negative 1, and because that negative 1 has a parentheses, it is not included in the solution. Solving inequalities. Follow the same rules to solve an inequality as you do an equation. You do want to remember that you have to switch the inequality symbol if you multiply or divide by a negative number. So the steps for solving inequalities, again, are exactly the same as solving equations, except for that last little bullet. If you multiply or divide on both sides by a negative number, then you have to remember to switch or flip the inequality symbol. Looking at example number 3, it says 5v plus 1 is greater than 7v minus 17. I'm going to subtract the 7v from both sides. 5v minus 7v is negative 2v. Bring down the plus 1 is greater than, bring down the negative 17. Then I'm going to subtract the 1. Negative 2v is greater than negative 18. And then divide both sides by a negative 2. Now, because I've just divided both sides by a negative number, the inequality sign is going to flip. Negative 18 divided by negative 2 is a positive 9. So I need to graph v is less than 9. So again, you're just putting numbers on there like on a number line. Because it says v is less than 9, that's going to be an open circle, and you're shading anything that's less or smaller than 9, which means you're going to shade left. Interval notation, left to right, it goes, everything that you have shaded goes to negative infinity up to a 9. Infinity always gets a parentheses. Open circles get parentheses. So my interval notation there says negative infinity to 9. Let's look at number 5. Example number 5 says 12p plus 52 is greater than negative 2 times 4 minus 2p. So we're going to distribute 12p plus 52 is greater than negative 2 times 4 is negative 8. Negative 2 times negative 2p is a positive 4p. Now you've got p's on both sides. I'm going to subtract 4p. 12p minus 4p is 8p. Then what we need to do is subtract the 52. And we have 8p is greater than negative 60. And then we want to divide by 8. And we get p is greater than. Notice that we divided by a positive number, therefore the inequality sign does not need to change. Negative 60 divided by 8 will reduce to negative 15 over 2. Which may be a little difficult for y'all to identify where it is on a number line, but I'm going to make this easy. So if this is negative 15 over 2, then to the right of that is negative 14 over 2. And what is negative 14 over 2? That would be negative 7. So I'm going to go ahead and change this to a negative 7. The next one's going to be a negative 13 over 2. Going to the left, negative 16 over 2 would be a negative 8. Negative 17 over 2. So that kind of helps you hopefully fill in some of those fractions. And it is an open circle at negative 15 over 2. And it says greater, so we're going to go to the right. For my interval left to right, it starts at negative 15 over 2 and goes to positive infinity. And they both are going to get parentheses because infinity is not an ending point. So it has to have a parentheses, and negative 15 over 2 is an open circle. All right, let's jump to number 7. 3 times 8x minus 9 is greater than 4 times 6x plus 1. Again, the first step is to distribute. 3 times 8x is 24x. 3 times negative 9 is negative 27. Greater than. 4 times 6x is 24x. 4 times 1 is 4. You have variables on both sides, so we're going to subtract. I'm going to subtract this 24x. Now, what happens here is just like what happened in equations. Your x's are going to subtract out. And y'all, that's why I do variables first. If you do numbers first, it can get a little confusing. You may not be able to quickly figure out what the answer is here. So you have to look at what's left. You have to decide, is that true or is that false? Is negative 27 greater than 4? No. It is not. So my solution is no solution. There is nothing that works. Because this is a false statement, my answer is there is no answer. So there is no interval notation. You're just going to tell me it's no solution. If there are no solutions, then there's absolutely nothing on your number line that's going to need to be shaded. Let's look at number 11. Number 11 says 11x minus 4 is less than or equal to 6x minus 3 minus 5x. So we still need to distribute on this one. There's that -1 that's in front of the parentheses. So we're going to distribute. -1 times 3 is a -3. -1 times -5x is a positive 5x. Now you got too much stuff on the right side, so let's combine some like terms. Remember that when you're combining like terms, you're just going to do exactly what it says to do. 6x and 5x are the same, so I'm allowed to add them together. 6x plus 5x is 11x. Bring down the -3. On this one, if we subtract the 11x, the same thing's going to happen as what happened in the last example. Your variables are going to subtract out on both sides. Now, what you have here is -4 is less than or equal to -3. Is -4 less than or equal to -3? It is. All day long. All day long, that is true. And because it's true, our answer is technically all real numbers, which means my whole entire number line would be shaded. Every number is going to make that inequality true. Interval notation here. Far left is -infinity. Far right is positive infinity. And my interval notation is going to be -infinity to positive infinity. I would like to look at number 12 really quick. I've got a big giant fraction. Hopefully at this point you've gotten used to what to do with these big giant fractions, which is going to be to multiply both sides by a -2. Now, caution, red flag. We are multiplying both sides of an inequality by a negative number. Typically that happens in the very last step. But if you'll notice, it's happening in the very first step here. We're multiplying both sides by negative, so the very first thing I'm going to do is flip that inequality. Now these -2's are going to go away. I'm going to go ahead and distribute here. And then I'm going to distribute the -2 on the other side. The left side of my equation has some like terms. I'm going to go ahead and combine those. What does it say? 4 minus 50. 4 minus 50 is -46. Bring down the plus 10w. Then I'm going to add 2w. Then I'm going to add 46. And I'm running out of space here. Hopefully you guys can still follow. So then I've got a 12w is greater than -14 plus 46 is going to be a positive 32. Divide by 12, and it does not go evenly. I did divide by a positive 12. So my inequality sign is going to stay as a greater than symbol. 32 over 12. For those of you that need a little help reducing your fractions, it's going to become 8/3. And again, the quickest and easiest way is just go ahead and put your 8/3 on here. I go into the right increases. So the next one's going to be 9/3, which is 3, and then 10/3. Going left, we get smaller, 7/3, and then 6/3, which is 2. Greater than 8/3. Open, going right. My interval is going to go from 8/3 to positive infinity. And in both of those cases, we're going to have parentheses because that is an open circle. Set notation, I'm not too worried about set notation. I can talk really quick. Set notation is another way of expressing the solution to an inequality. Example, x is greater than 5 in set notation. It's a very formal way of writing it. That's what it looks like, and you read it as the set of x values such that x is greater than 5. I will not test you on that. It is something that I do need you to be familiar with. We will work on the assignment that goes with this lesson in class later. Let me know if you have any questions.